Okay, this is your algebra review day 2. Once again, these are all things that were covered in your summer packet. So nothing should be I forgot how to do that. It should be something that you've brushed up on over the summer. So let's start with this one right here, solve the system algebraically. We did a solving the system on the day 1 notes. Remember, if you have a system, 2 equations, 2 variables, substitution, elimination, graphing, matrices out because it's no calculator. Graphing, there's no graph paper. So substitution or elimination. Substitution I would use if there's a variable that's already solved for. In this case, there is a variable that's already solved for. Y is. So I'm going to use substitution. How substitution works is that I know this is the exact same thing as y, so I'm going to substitute it into the other equation for y, so there's no longer any y's in the equation. So I have 3x minus 2 times the quantity of, instead of writing y, I'm writing 3x minus 1 equals negative 7. Now I need to solve this. Distribute your negative 2, that's negative 6x. Distribute your negative 2, that's plus 2y equals negative 7. Combine like terms, that's negative 3x plus 2 equals negative 7. Subtract 2, negative 3x equals negative 9. X equals 3. Now I need to solve for y. The easiest way to do that is to plug it into this equation that's already solved for y. So y equals 3 times 3 minus 1. Y equals 8. So my solution is the ordered pair x comma y. 3 comma 8. If you feel like I'm going fast through the algebra 1, it's because it's algebra 1, right? So I am going to be going fast through that type of stuff. Okay, next one, we did factoring yesterday, but this is just to remind you of how to factor. And this next 2 problems too, so if you want to pause the video and try them yourself and come back, I think this is a great point to do that at. Okay, so in case you need to see this, remember when factoring, the first thing you ask yourself is there a GCF? Is there something that all 3 of these have in common? The answer is yes. They have 3x in common, so I'm going to factor out the 3x. X squared minus 4x minus 5. Now remember, it's factor completely, so look at what's left over. Is this factorable? The answer is yes. I'm looking for 2 numbers that multiply to give me negative 5, add to give me negative 4, which are negative 5 and 1. Divide by the lead coefficient, which is 1. If you're saying it's 3, no, it's not. I'm looking at this right here. The lead coefficient is 1, right? This is my x term and my x term. So now I'm going to write down my final answer. The 3x does not jump off the paper. 3x times the quantity of, this is x minus 5. This is x plus 1. Okay, next one. All right, I need to factor this. Is there a GCF? No. There's 3 terms though. A times C is 12. B is 7. 2 numbers that multiply to give me 12 and add to give me 7, 4, and 3. Divide by your lead coefficient, which is 1 this time. So remember, this is my x term, this is my x term. But this time you should notice it's x to the 4th. So this has to be an x squared and an x squared. So now I have x squared plus 4 times x squared plus 3. Factor completely, so now I have to look to see if this is factorable. It's 2 terms, so I'm looking to see if it's a difference of squares. It's addition, so it's not. 2 terms, so I'm looking to see if it's a difference of squares. It's addition, so it's not. So this is as factored as this is going to get. All right, next is solve each. Okay, so we did this yesterday, or on the last notes. I shouldn't say yesterday, but on the last notes. Solve for all solutions, meaning real and imaginary. Okay? So first thing I need to ask myself when this is a quadratic. I know it's quadratic because there's an x squared. So I need to ask myself is, can I solve by square rooting? So is there only an x squared? The answer to that is no. So I have to say I have to try to factor it. In order to factor it, it has to be equal to 0. So first thing I'm going to do is add 6 to both sides. X squared plus 6x plus 6 equals 0. So now I'm going to try to factor it. Is there a GCF? No. Two numbers that multiply to give me 6 and add to give me 6 does not exist, so therefore I cannot factor it to solve. So I'm going to use the quadratic formula instead. X equals the opposite of b, negative 6, plus or minus the square root of b, which is 6 squared, minus 4 times a, which is 1, that's right here, times c, which is 6, that's right here, all over 2 times a, which is 1. Clean this up. Once again, these are the same steps that I used yesterday. You're going to do negative 6 plus or minus the square root of. First thing you're going to clean up is this. That's 36. Second thing that you're going to clean up is this. That's negative 24. The third thing you're going to clean up is this, which is 2. Fourth thing that you're going to clean up is this. X equals negative 6 plus or minus the square root of 12, all over 2. If you're saying, can we just put this in our calculator? You should not have a calculator anywhere near you. Okay, I know there's one on your iPad, but you're not using one. You're not allowed to use one. Okay? All right. Next step, simplify root 12. Biggest perfect square that goes into 12 is 4, and it goes in there 3 times. The square root of 4 is 2. So now I have x equals negative 6 plus or minus 2 root 3 all over 2. Last step, divide by 2. Divide by 2. X equals negative 6 divided by 2 is negative 3 plus or minus 2 root 3 divided by 2 is root 3. And there's my answer. All right, next one. Quadratics. There's an x squared. Can I solve by square rooting? The answer is yes, because it's just an x squared. You don't see an x squared and an x physically in the problem. Okay, but in order to do that, in order to solve by square rooting, I can square root this, right? So I have to get that by itself. So I have to get that by itself. Step number 1, subtract 1. 2 times the quantity of x minus 3 squared equals negative 40. Still need to get this by itself so I can square root. Divide by 2. X minus 3 quantity squared equals negative 20. Now I can square root to solve. Square root. Don't forget when you square root to solve, you have to use plus or minus. X minus 3 equals plus or minus. Now I need to simplify the square root of negative 20. So first off, it's negative. So I know I is in the answer. So I'm going to put down I right here because I know that's in the answer somewhere. Okay? So now just focus on the root 20. What's the biggest perfect square that goes into 20? 4 goes in there 5 times. What's the square root of 4? 2. So this is actually going to be a 2i root 5. Last but not least, add 3 to both sides. So now I have x equals 3 plus or minus 2i root 5. Now, we're going to leave our answer like this is because do you know what 3 plus 2i root 5 is? No clue. Do you know what 3 minus 2i root 5 is? No clue. So there's no way to simplify this answer anymore. Okay. Next, we have the sum and difference of cubes, which is a factoring pattern. Just like a difference of squares is a factoring pattern. So just like x squared minus 49 factors to x plus 7 times x minus 7, okay, which is a pattern that we know. These are difference of cubes, which has a special factoring pattern, okay? So let me explain that special factoring pattern real quick. So a cubed plus b cubed. This is a sum of cubes, right? It's a sum of 2 cubes. A is cubed and b is cubed. So in order to factor this, here's what you're going to do. You're going to copy the base. So pretend like the cubes weren't there. That's a plus b. Then you are going to, look at this right here, you're going to square the first term. That's the first term right there, so that's a squared. Take the opposite of this sign, which is minus. Then you're going to take the product of these two things. A times b is ab. And then you're going to square the last term. This is the last term right here, so plus b squared. And this is what it factors to, okay? So keep in mind if it was a minus b squared instead, you would still copy the base. This would become a minus b. You would still square the first term, which would still be a squared. You would take the opposite of that sign, so that would be plus. Take the product, a times b is a times b still. Square the last, b squared is still b squared. Okay, so, mnemonic device to help you remember this. Because if you're like, oh, what do you do? S-O-P-P-S, SOPs. Square, opposite, product, this P is for a plus sign, and then square the last. Okay, so let's try this. So first off, this is a cube, this is a difference, and this is not written as a cube, but it can be, so let's do that. So this is x cubed minus 8 is the same thing as 2 cubed. And now we can use our special factoring pattern. You're going to copy the base. So remember the base is x minus 2. That's going to be your binomial. Now I just have to get my trinomial. You really don't need the original anymore. S-O-P-S. S stands for square. Square the first term. X squared. O stands for opposite. Take the opposite of the sign. Plus. P stands for product. Multiply those two terms. X times 2 is 2x. P stands for plus. S stands for square. So square the last term. Negative 2 squared is 4. There you go. Okay. Some people will say like, oh, do we have to factor this? That will never be factorable. This is the special factoring pattern. If it was factorable, this wouldn't be the pattern. All right, let's look at the next one here. This one, the 125 is not written as a cube, so we have to do that. That's 5 cubed. And we have x cubed plus 27 is not written as a cubed. That's 3 cubed. All right, so remember, step number 1, copy the base. 5x plus 3. Now I need to get my trinomial. I don't need the original at all anymore. SOPs. S stands for square. Square the first term. What's 5x squared? What's 5x times 5x? 25x squared. Opposite, so minus. P, product. Multiply these two. 15x. P plus sign. S square the last term, 9. If you're like, wait, I want to try one now. There's some in the work that you're going to do after this, right? In the practice. So I suggest that maybe you should pause and even go try your practice on those two real quick, just to see, make sure you're doing it correctly. Okay, we have 2 more topics left. Graphing quadratics and the properties of imaginary numbers. Okay, so let's start with graphing quadratics. So we have 2 different forms here. We have standard form and we have vertex form. Vertex form, I personally believe, is easier, but there's parts that are easier about slope-intercept, standard form also. Okay, so standard form is in the form y equals ax squared plus bx plus c. Okay, so to find your x value of your vertex, to find the x value of your vertex, you're going to use the opposite of b over 2 times a. So in this particular one, x equals the opposite of b, which is 4, over 2 times a, which is -1. So that's -2. So that means the x value of my vertex is -2. To find the y value, I'm going to plug in -2. So I'm going to find f of -2. So that's negative. That's this negative right here. And now I'm going to plug in -2 here. So -2 squared minus 4 times negative 2 minus 3. Okay? All right, now I'm going to clean this up. Make sure you're using orders of operations and not using a calculator. Orders of operations say do inside the parentheses first. There's nothing to do inside. Next, it says do exponents. Negative 2 squared is 4. Now it says do multiplication left to right or division. So multiplication or division left to right. Here's multiplication right here. Please realize this is negative 1 times 4, which is negative 4. Negative 4 times negative 2, which is positive 8, and then minus 3. Now I can do addition or subtraction left to right. So that's 1. But once again, if you're like, oh, she's not looking, so put in my calculator, you're going to give yourself a huge disadvantage when you're taking an assessment and you can't use a calculator. Okay, so here's my y-intercept, negative 2, 1. Or sorry, my vertex, negative 2, 1. Now I move on to my y-intercept. Remember, your y-intercept is the point 0 comma something. So what we're going to do is we're going to plug in 0 for x. That's what this says here, plug in 0 for x. If I plug in 0 for x, nothing there, I get negative 3. Also, I know that that point's reflected over this line of symmetry right here. So I know that I have another point right here. Okay, so far. Oops. All right, now I need my x-intercepts. My x-intercepts I get is when y is 0. Okay, notice it says intercepts too because there can be more than one. If you look right here, there's going to be more than one, right? It's going to hit it more than once. So now we have to find our x-intercepts. So I'm going to set y equal to 0. So I'm going to put 0 here instead. 0 equals negative x squared minus 4x minus 3. Okay, so this is a quadratic. Can I solve by square rooting? No. There's an x squared and an x. So now I'm going to ask myself, is it factorable? So first thing I'm going to look for is something they all have in common, a GCF. Well, I see that this starts with a negative and they all have a negative in common, so I'm going to start by factoring that out because I don't like it. All right, now I'm going to look and see what's left behind. Is that factorable? The answer is yes. Two numbers that multiply to give you 3 and add to give you 4 are 3 and 1. So x plus 3, x plus 1. Set each factor equal to 0 and solve. So how many factors do I have? 1, 2, 3. Okay? So I can set negative, I don't like that. Set negative 1 equal to 0. Set x plus 3 equal to 0. Set x plus 1 equal to 0. All right, solve this equation for x, you get negative 1. Solve this equation for x, you get negative 3. Solve this equation for x, there is no x, so you can't solve that. So I actually have two x-intercepts. I have negative 3, 0, and negative 1, 0. Okay, next one. Vertex form. Vertex form is in the form y equals a times x minus h squared plus k, where hk is your vertex. So notice right here in the equation, once again, it's a negative, so you're going to take the opposite of whatever's in there. So if this is a negative 2, h is positive 2. If you look at k, let's take exactly what it is, so it's a negative 6. So right away notice that's why vertex form is easier as when it comparatively when you're looking for the vertex. All right, now I need the y-intercept. So y-intercept, plug in 0. Plug in 0 for x and see what you get for y. So I'm plugging in 0 here. So I have 0 minus 2, square it, minus 6. That's negative 2 inside the parentheses. Negative 2 squared is positive 4, minus 6, which is negative 2. So 0, negative 2. Once again, this right here is my vertex. My graph has to be symmetric, so that means that there has to be another point right here at 4, -2 so far. All right, x-intercepts. This is where y is equal to 0. So there might be more than one. There can also be none, right? Because if you think about it, it can look like this. There's no y-intercepts right there. Or sorry, x-intercepts right there. All right, let's see. You can tell that there's going to be x-intercepts, but let's see where they're at. I'm going to put 0 equals x minus 2 quantity squared minus 6. Okay, quadratic. Can I solve this using square roots? The answer is yes. But I got to get this by itself so I can square root. So I'm going to add 6 to both sides. And now I can square root to solve. Square root, don't forget to do plus or minus. All right, I have x minus 2 equals plus or minus. Do I know the square root is 6? No. Are there any perfect squares that go into 6? No. So root 6 is not simplifiable. I'm going to leave it as root 6. Add 2 to both sides. X equals 2 plus or minus root 6. 2 plus or minus root 6. Realize that is 2 x-intercepts. You don't have to separate them. This is technically 2 plus root 6 comma 0 and 2 minus root 6 comma 0. So if you think about it, they're decimal answers. We don't have to get them perfect, so we're just going to graph our quadratic and make sure it's good to go. All right, last but not least, we have to do imaginary properties. So imaginary numbers are in the form a plus bi, where this is the real part and this is the imaginary part of the number. All right, so simplify each completely. So this is just subtraction, okay? So I have to do 6 minus 2, which is 4. That's the subtract the real parts and subtract the imaginary parts. 3i minus negative 5i. So if you think about that, what you could do instead is, since it's subtraction, is you can distribute the negative, right? So this becomes positive, distribute the negative, so that's negative, that's positive, and then just combine like terms. 6 and negative 2 is 4, 3i and 5i is 8i. Done. All right, next one, 2 plus I quantity squared. Okay, when I square something, what's the shortcut of writing, okay? So when I say 4 squared, what's that the shortcut of writing? And not 16. It's the shortcut of writing 4 times 4, right? So 2 plus I quantity squared is the shortcut of 2 plus I times 2 plus I. Okay, now I need to multiply this out. Okay, so I'm going to start by distributing this 2 to both of my terms in the second binomial. So 2 times 2 is 4. 2 times I is 2i. Now I'm going to distribute my second term, which is I. I times 2 is 2i. I times I is I squared. All right, now I have to clean this up. Okay? So first off, what you have to recall is that we don't ever leave I squared in an answer, because what is I squared equivalent to? Negative 1. So cross this off, put negative 1 here. And now I can add the real parts. 4 and negative 1 is 3. And then 2i and 2i is 4i. All right, this one here is already set up for multiplication. 4 times 4 is 16. 4 times 3i, 12i. Now I got to distribute the negative 3i. Negative 3i times 4 is negative 12i. Negative 3i times positive 3i is negative 9i squared. All right, once again, I don't want to keep this in here. Remember, it's equivalent to negative 1. So I'm going to change this negative 9 times negative 1 to a positive 9. Combine my real parts. 16 and 9 is 25. 12i and negative 12i cancel out, so the answer is just 25. Sorry about all the emails that I get as we go through these. I'm the freshman sponsor for iPads. Okay, last but not least is simplifying I to the 18th. I can simplify I to anything. I can simplify I to the 1,464,282. I can simplify anything I to any power, okay? There's only 4 possible things that I could simplify to. Okay, so first off, you have to know your equivalencies. So what is I? Once again, I is the square root of -1. Okay, but we choose to write down I instead because it's much prettier. Okay. Then we have I squared. Oops. Then we have I squared. I cubed, I to the 4th, I to the 5th, I to the 6th, and I'll stop there. Okay. I squared, we said, is -1. All right? Okay, what about I cubed? Okay. Isn't I cubed the same thing as I squared times I? So it's just the same thing as -1 times I, which is -I. I to the 4th is the same thing as I squared squared. So what's -1 squared? 1. I to the 5th is the same thing as I to the 4th times I. So what's 1 times I? I. I to the 6th is the same thing as I to the 4th times I squared, so it's 1 times -1, -1. And I could keep going on and on and on. So let's just put I here. If you notice the pattern here, it goes I, -1, -I, 1. I, -1, -I, 1. Okay? So it depends on if it's divisible by 4, then it's equivalent to 1. And you can figure out what it is. So if you look at this one here, I have I to the 18th. How I'm going to figure it out is I'm going to say, okay, what's 18 divided by 4? And I need to know what the remainder is. So how many times is 4 going to 18? It goes in there 4 times, and there's a remainder of 2. So I to the 18th is equivalent to I squared, okay, because of the remainder 2 here. And what's I squared equivalent to? -1, and that's my answer. Okay, so if you know these 4, you're good. I know that was a little confusing, but it's just to have the idea of that can only be 4 answers is good. Okay, long one, but lots to recall, so stop by